Okay, so today we will discuss some problems of real analysis from CSIR NET 2025. So let us start with the problem 498. We are given two non-empty subsets of N, A and B, with cardinality of A greater than equal to 2, and S1 be the collection of all injective maps from A to B, and S2 be the collection of all surjective maps from B to A. So then we have to check which one of the following is true. So for checking first one, let us assume cardinality of A is 3 and cardinality of B is 4. So then the number of 1-to-1 maps from A to B is 24, because this is 4 factorial by 1 factorial, which is 24. But the number of surjective maps from B to A is summation k from 0 to 3 minus 1 power k, 3 choose k, 3 minus k power 4. So you will get 36. So cardinality of S2 is strictly bigger than cardinality of S1. So that means this option is not true. So for checking the second one, if B is N, then there exists a 1-to-1 map from S2 to B. Yeah. So let's say B is N. And yeah, so let us assume cardinality of A is 2. So S2 then be the collection of all surjective maps from B to A, and this thing is bijective with collection of all sequences with entries 0, 1, and we know this collection is clearly uncountable. So the cardinality of S2 is greater than cardinality of natural number LF naught. So basically this sequence has cardinality 2 power LF naught. So this is much larger. So this is not true. For checking 3, let's say B equal to N and A is finite, then there exists a 1-to-1 map from B to S1, and A is finite. So let's say order of A is 2. So you can generalize this process by iterating this. So again, for simplicity, let A equal to 1, 2. So let us define a map phi from N to S1, which is collection of all functions from A to N injective is defined by phi of N equal to F. So we define F as F of 1 is N and F of 2 is N plus 1. So clearly phi is injective. So 3 is correct. If A is finite, again let us assume A is 2 and put B equal to N. So then S2 be the collection of all surjective functions from N to A, which is uncountable, as we pointed out this before, because yeah, so let us do it here. So Let a is 0, 1 and b is n, and collection of all functions surjective from n to 0, 1 is uncountable. So this is not true. Okay. Let's move on to the next problem. F is a function from r minus q to r minus q defined as fx equal to 3x plus 2 divided by 4x plus 3. Suppose that a sequence converges to the real number L. So the point is r minus q is dense. Okay, just a remark. And the sequence xn is defined by xn plus 1 equal to xn. So xn converges to a real number. So xn plus 1 equal to 3xn plus 2 divided by 4xn plus 3. So as xn has a limit, L equal to 3L plus 2 divided by 4L plus 3. Yeah. So remember that xn's are irrational. Okay. So 4L squared plus 3L equal to 3L plus 2. So L square equal to half. So L equal to plus minus 1 by root 2. So if L is positive, then L equal to 1 by root 2. This answer is true. Okay, so let us move on to the next problem. Problem number 4100. So given a function fx equal to x times log of 1 plus 1 by x. Okay, let us check the first option. So by definition f of x is greater than or equal to 0. Actually f of x is strictly greater than 0, and limit x tends to 0, x times log 1 plus 1 by x is 0, and limit x tends to infinity plus infinity x times log 1 plus 1 by x is 1. Yeah, so basically this is limit x tends to infinity log of 1 plus x divided by x. So this is the limit is 0, and fx is positive for all x into 0 comma infinity. So the point is fx is bounded. So let us draw the picture. So x equal to 0 plus infinity. So we can choose m1 comma m2 such that in 0 comma m1 fx is bounded, and in m2 comma infinity fx is bounded. So and fx is continuous, so in m2 comma m2 fx is also bounded. So that means fx is bounded, so first option is not correct. So for the second option, fx is increasing, let us write the function and calculate the derivative, first derivative, plus x minus 1 by 1 by 1 plus x. So limit x tends to 0 plus if prime of x is positive infinity, and limit x tends to plus infinity if prime of x is 0. So if we further differentiate this, so if double prime of x equal to 1 by 1 plus x minus 1 by x plus 1 by 1 plus x square, right? So if we calculate this, this is x times x plus 1 whole squared, x times x plus 1 whole squared, x times x plus 1 minus x plus 1 whole squared plus x. So which is x squared plus x minus x squared minus 2x minus 1 plus x divided by x times x plus 1 squared. So x 2x x squared, so which is minus 1 by x times x plus 1 squared. So as I don't have enough space, so I want to remove the calculation. So yeah, so if double prime x equal to minus 1 by x times x plus 1 square, which is strictly negative. So if prime of x is strictly positive, decreasing, is strictly decreasing, so and x tends to 0 plus if prime of x is positive infinity, and x tends to plus infinity if prime of x is 0. So I claim that this will imply if prime of x greater than 0. Proof. Let us assume if prime of c is less than equal to 0 for a c, for a c belongs to 0 to infinity. Okay, now as so if prime of x is strictly decreasing, so that means take c plus 1. So what is f prime of c plus 1? Is strictly decreasing, so less than equal to f prime of c. Correct? So as f prime is strictly decreasing, so that means it is not equal to, so f prime of c plus half strictly less than f prime of c. So then for all x strictly greater than c plus half, we have f prime of x is strictly less than f prime of c plus half. Taking limit both sides, we have limit x tends to positive infinity f prime of x less than equal to f prime of c plus half. And we know this limit is 0 by this. And f prime of c plus half is strictly less than f prime of c. Right? So that is not possible because we have 0. Okay, that is not possible because we have 0 is strictly less than f prime of c. But we assume that f prime of c is less than equal to 0. So this is a contradiction. So our assumption is wrong. So f prime of c, so this assumption is wrong. So that means for all x belongs to 0 comma infinity, f prime of x is strictly greater than 0. So that means f of x is increasing. So this is true, and we calculate limit x tends to infinity f of x, which is 1. So it is not correct. F is decreasing, which is not correct. Okay. Okay, let's move on to the next problem. They are given some sequence of functions, so we have to check the uniform convergence of this sequence of functions. So let us check the first option. So let us assume fn converges uniformly to f. So that means for half there exists n such that if n of x minus fn of x is strictly less than half for all x inside 0 comma 1. Okay. Sorry, fn of x minus f of x. So now put x equal to 1 by n. So fn of 1 by n minus f of 1 by n is less than half. But so first option is sequence of function converges to a continuous function f. So as f is continuous, so f of 1 by n converges to f of 0, and f of 0 is limit n tends to infinity fn of 0, because uniform convergence implies pointwise convergence, and fn of 0 is 0 for every function, so it is 0. So f of 1 by n converges to 0. Okay, but we have fn of 1 by n minus f of 1 by n is less than half for all n greater than equal to n. What is fn of 1 by n? So by the definition, fn of 1 by n is 1. So we have 1 minus f of 1 by n is less than half for all n greater than equal to n. But limit n tends to infinity, n tends to infinity f of 1 by n is 0. Correct? So that is not possible here. So this option is not correct. So now given an alpha belongs to 0 comma 1, let us assume alpha is not equal to 0 and 1, because fn of 0 is 0 for every n, for all n. Fn of 1 is 0 for all n. So let us assume that alpha is inside, basically alpha is inside the open interval 0, 1. So then there exists a n such that n times alpha is greater than 2 by Archimedean property. Now for all n greater than equal to n, we have n times alpha is greater than 2. Correct? So basically alpha is greater than 2 by n. So alpha is inside the interval then. So that means for all n greater than equal to n, if n of alpha is 0. Right? So we have limit n tends to infinity fn of alpha is 0. So that means fn converges pointwise to 0 function. So convergence pointwise to the 0 function. This is true, this is wrong. Okay. So let us move on to the problem number 4104. So X be a real vector space of all twice differentiable real valued function on 0, 1. Consider the linear map. Which of the following statements are true? So first of all, calculate the image of the function. So to calculate the dimension of x mod curve phi, so the point is, if you have a linear transformation from x to R3, to calculate dimension of x mod curve phi, you have to calculate the dimension of, what is the dimension of the image of phi, right? Because this is isomorphic to the image. So let us compute that. So take f of x equal to 1, the constant function. Then phi of f equal to f of 1, which is 1, f prime of 1, which is 0, 0. Let us denote this is f1. So yeah, define, yeah, f2 is x minus 1. So the value is 0, 1, 0. Then define f3 is x minus 1 squared by 2. Phi of f3 is 0, 0, 1. Okay. Now we know these three vectors generate R3. This generates R3. Three vector generates R3. So x mod curve phi is isomorphic to R3. So we have first option is correct. Curve phi is finite dimensional. So the point is, if you look at all the polynomials x minus 1 power k, where k is greater than equal to 3, then fk, let us define fk, then phi of fk is 0. So fk are inside the kernel, and these are clearly linearly independent for different k's. So this option is not correct, as we calculated the dimension of x mod curve phi is 3. So this is also not correct. F is finite dimensional? No, of course not. F is not finite dimensional, because x contains x to the power k. These functions, x contains x to the power k functions. So, and these functions are linearly independent to each other. So it is not finite dimensional. Okay. Okay, let's move on to this problem number 4106. So here also given some sequence of functions. Yeah, we have vector space spanned by f1, f2, f3. Okay, now let us first check the first option, f4 is inside V or not. So let us assume c1 f1 plus c2 f2 plus c3 f3 equal to f4. Let us assume f4 is inside that. So evaluate at x equal to 0 first. So f1 of 0 is 1, f2 of 0 is 2, f3 of 0 is 3. So c1 plus 2c2 plus 3c3 equal to 4, and evaluate at pi. f1 of pi is 1, f2 of pi is minus 2, and f3 of pi is 3, f4 of pi is minus 4. So we have c1 minus 2c2 plus 3c3 equal to minus 4. From that we have c2 equal to 4, c2 equal to 2, and c1 plus 3c3 is equal to 0. Okay, now evaluate at x equal to pi by 2. So c1 of f1 of pi by 2, sine of, so f1 of sine this is 1, so c1 plus f2 of pi by 2 is 0, and f3, so sine 3 pi by 2 by sine pi by 2. So yeah, which is the value of f3 of pi by 2. So yeah, so we all know the answer. This is minus 1. So minus of c3 equal to, and f4 of pi by 2, that means 0. So c1 minus c3 equal to 0. Okay. So from these two equations, we have c1 equal to c3 equal to 0. So that means, and c2 equal to 2 we have. So that means 2f2 equal to f4, but which is clearly not possible, right? Because 2f2 again, so 2f2 equal to f4. So that means sine 2x divided by sine x equal to sine 4x divided by sine x when x is inside 0 to pi. Okay, and whenever x is inside 0 to pi, sine x is non-zero, so we can cancel this. So 2 sine 2x equal to sine 4x. Okay, now just evaluate it at x equal to pi by 4. Right, so for x equal to pi by 4, 2 times pi by 2 sine pi by 2 equal to 0, and this is not possible. So that means f4 is not inside V, so this is wrong. So f1, f2, f3 is an orthonormal basis of V. So for doing that, I want a different page because there is no enough space. Okay. Okay, maybe check the third option first. So the dimension of V is 2. So let us assume C1 F1 plus C2 F2 plus C3 F3 is 0. So we want to show F1, F2, F3 are linearly independent. So again the same technique. So let us evaluate at x equal to 0. So C1 plus 2C2 plus 3C3 is 0. Evaluate at pi. C1 minus 2C2 plus 3C3 is 0. And from that you have a C2 equal to 0 and C1 plus 3C3 is 0. Now evaluate at pi by 2, you will get C1 minus C3 is 0. So from these two equation you have C1 equal to C3 equal to 0. So these functions are linearly independent. So this is also not correct. So for orthonormality or orthogonality, so so let us assume so the inner product given is 2 by pi 0 to pi f of x gx sine square x dx. So we will do a general phenomena. So fn times fn. So when we integrate something, we don't care about the endpoints. So in the interval 0 to pi open interval, f of nx is sine nx by sine x. Okay, so this is 2 by pi 0 to pi sine mx times sine nx dx. So just put the formula of that guy. So this is 1 by 2 cos m minus nx minus cos m plus nx, okay, dx. We'll do separately. So when m is not equal to n, then 0 to pi sine, okay, let us just integrate it, n minus m x by m minus n minus sine m plus n x divided by m plus n. And evaluating it from 0 to pi, we will have 0. When m equal to n, then we will have half 0 to pi 1 minus cos m plus nx dx, which is 1 by pi x minus sine 2nx as m equal to n by 2n 0 to pi. So evaluating this will give 1. So that means f of m times f of n is 0 when m is not equal to n, and f of n times f of n is 1 when m is equal to n. So that means f1, f2, f3 forms an orthonormal basis. So that means orthonormal basis. Sorry, I have a problem in my pen. So this option is correct. This is wrong. Yeah, this was a nice problem. Okay, so moving to the next problem, problem number 4107. So V is a vector space of all polynomials of the form ax cube plus bx square plus cx. Okay, so QF is defined by this. So let us check it is positive definite or not. So clearly QF is greater than or equal to 0 by definition. And now if we have f prime of t whole squared dt is 0, that will imply f prime of t is 0, and that will imply f of t is constant. But f of t is a polynomial of the form x cube plus bx square plus c. So the only choice for the constant function is 0 function. So that means it is positive definite, and q of lambda f lambda square f prime t whole square dt is lambda square qf. So that means this option is true, so we will not take this because they're asking about the false statement. Q takes every positive value, so let us choose f to be root over a times t, which is a valid thing because this is of the form x cube plus bx square plus cx with a and b as 0. So then q of f equal to minus 1 to 1 root a whole square dt, which is nothing but 2a. As a is arbitrary, we have q takes every positive real value, so we will not take this because this is a true statement, and q of x equal to minus 1 to 1 dt, which is 2. That means this is also true, so we will not take this. But q of x plus minus x equal to q of 0. So q of 0 is what? By the definition, q of 0 is f for the 0 function, f prime of t is 0. So integration minus 1 to 1 0 of dt, which is 0. So and q of x, as we compute, this is 2, and q of minus x equal to again q of x, which is 2. But q of x plus q of minus x is 4, but q of x plus minus x is 0. So this is not true, so this is false. Okay, let's move on to the next question. So if from C to C be a polynomial map and R is greater than 0, and y r equal to 0 1 to C be the map t goes to r times e to the power 2 pi I t, suppose there exists a C such that, okay, then which statements is false? Okay, so just calculate the integral 2 pi I t f prime is r times 2 pi I e to the power 2 pi I t mod dt, okay, which is 2 pi r times integration 0 to 1 mod of e to the power 2 pi I t is 1, so integration f of r e to the power 2 pi I t dt. Okay, now let degree of f is n, and f equal to a n z to the power n plus a n minus 1 z to the power n minus 1 plus dot 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 a naught. So then f of z by z to the power n equal to a n plus a n minus 1 by z dot dot a naught by z to the power n. So mod of fz by z power n equal to mod of a n plus a n minus 1 by z dot 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 a naught by z to the power n. Now by triangle inequality, we have mod of a n plus a n minus 1 by z plus dot 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 a naught by z to the power n is greater than equal to a n minus 1 by z plus dot 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 a naught by z power n, and a n minus 1 by z plus dot 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 a naught by z to the power n is less than equal to summation of its mods n minus 2 by z square dot a naught by z power n. Now, so we want to check when z equal to r times e to the power 2 pi it. Okay. Now if mod z equal to r tends to infinity, or r is very large, then we have for sufficiently large r, this quantity, let us define this quantity is a is less than or equal to mod a n divided by 2. So we are increasing the mod of z. So as mod z tends to infinity, or sufficiently large r, mod z equal to r, we have the quantity a less than equal to mod of a n by 2. So then this guy a n plus a n minus 1 by z dot dot a naught by z power n is greater than equal to a n minus mod of a n divided by 2, which is mod of a n by 2, and we assume that a n is non-zero because f n has degree n, a n is non-zero. So for sufficiently large r, we have f of z by mod of z to the power n is greater than or equal to a n by 2, mod of a n by 2, which imply mod of f of z is greater than equal to mod z power n times n by 2. Yeah, so when z equal to r times e to the power 2 pi it, for sufficiently large r, we have f of z is greater than equal to r to the power n times n by 2. So as we integrate 2 pi r 0 to 1 mod of f of r times e to the power 2 pi it dt, this integral is greater than equal to 2 pi r 0 to 1 r to the power n mod of a n divided by 2 dt, okay, which is 2 pi r to the power n plus 1 n by 2. Now you can clearly see that as r tends to infinity, this integral, the integral also tends to infinity. So we don't have any real c such that this is true. So that means c greater than 0, it is false. C has to be 0. C has to be 0. Has to be 0. Okay, and the polynomial has to be 0. Has to be 0 polynomial. Okay, so other three options are not. Other three options are true actually, so we will not take this. Okay. Okay, so let us move on the next problem. So X be the image of the interval 0, 1 under the Mobius transformation. Which of the following statements are true? So we have to find the image of this 0, 1, this interval. So let us compute first what is f of 0. Is minus I over I, which is minus 1. And what is f of 1? Is 1 minus I divided by 1 plus I, which is 1 minus I whole square divided by 2, which is minus I. Okay. Okay, let us draw the picture. So this is 0, 1, minus 1, minus I. So 0, image of 0 is minus 1, image of 1 is minus I. So as we notice that this f of z equal to z minus I divided by z plus I. So in 0, 1, the map z goes to is continuous. So it has a continuous image. Now check. So I want to check, can we cross a single point twice or thrice? I mean, can we cross a single point twice or thrice means we have to check the injectivity of the map. So it can happen that so line joining or curve joining minus 1 to minus I can be happen like this. So let us go. So yeah. Okay, let us draw a picture here again. So this is minus 1, this is minus I. So the path can be like this or this, or go halfway and then go backwards and then go half and then go to minus I. It can be happen like this. So you have to check this is injective or not. So z prime minus iz plus iz prime plus 1. So cancel this. So equating, we get z equal to z prime. So it is injective on zero comma 1. So on the circle, so yeah, so look at the picture on the circle. So this image of this thing is a continuous path joining minus 1 to minus I. So then let us compute the modulus of the image. So mod of z minus I divided by z plus I when z is inside 0 comma 1, which is x minus 1 divided by x plus I, which is 1. So the image, so let us write it here. The image of f image of 0 comma 1 is inside the circumference of the unit circle, and we showed that this is injective. So there are only two ways joining minus 1 to minus I. Is one way is here and one way is here, and as we showed this is injective. That means any path do not cross a single point twice. So two possibilities are there, so this path or this path. But if the path through first quadrant is happening, then one should have lie inside the image, right? But z minus I divided by z plus I equal to 1 has no solution. Okay. No, this has no solution. So that means the image is this path. So this is pi, the angle is pi, and this is 3 pi by 2. So 2 is the answer. Yeah, so x is a line segment joining -1 to -I. It is not true because we showed that image is contained inside the circumference of the unit circle. So this is not correct. This is line joining, this is the line segment joining -1 to 1, also not correct. X equal to e to the power I theta, theta belongs to minus pi by 2 to pi. So yeah, this is also not correct. This is not correct also, because we showed one is not inside the image, so this arc will not, this arc is not the image. Okay. Okay, so let us move on to the next problem. Problem number 4110. So which one of the following statements is true? So in all cases, f is an entire function. So for entire function, so consider summation an z to the power n. For entire function, this is a condition that 1 by r has to be 0. I mean, this radius of convergence is infinity. And what is 1 by r? 1 by r is lim sup of mod an power 1 by n. Okay. We want it to be 0. So let us check. Yeah, so for that problem, an is in f n derivative of f at 0 divided by n factorial. So let us write down. Yeah, so calculate this. So in first case, n factorial, if n0 by n factorial is 1 by n to the power n. For second, if n0 by n factorial is n to the power n. For third, if n0 by n factorial is 1 by n. And for fourth, we have if n0 divided by n factorial is n. So let us calculate the lim sups in all cases. So in first case, lim sup of nth root of, we are calculating nth root of mod n, right? So in case 1, lim sup of nth root of mod of an is 0. This is what we want. In second case, lim sup of nth root of an is n. So in second case, this guy is lim sup of n, so which tends to infinity. This we will not take this. And for third, this is 1 by n power 1 by n. Yeah, an is 1 by n, so we have to calculate 1 by n power 1 by n, and this limit tends to 1, which we will not take because this is entire. We want 1 by r is 0. If f is entire, 1 by r is 0. So and fourth, we have to calculate lim sup of n power 1 by n, which is also tends to 1, which we will not take. Yeah, we are taking an to be a fn 0 by n factorial because we know if z has an series expansion, Taylor series expansion at 0, and 0 divided by 2 factorial z square and so on. So we want this fz to be entire. So this one is a correct option. It is not true. So you can also do it by Cauchy inequality. So I don't have enough space here. Let us do it here. So Cauchy inequality. So we know f prime. So let's say f is an entire function from sigma to c, and sigma contains a closure of a disk of radius r, maybe, let's say. So then let's say around 0. Then we know by Cauchy inequality mod of n derivative of f at 0 is less than equal to n factorial times the supremum of f when you evaluated it at the circumference of that circle c divided by r to the power n, right? So yeah, I will show that all the other three options, these three options 2, 3 and 4, these three options will not satisfy this, inequality for large n. I will show that. So let us do that. Okay. So as f is entire, so if it's a function from c to c, okay, so then choose r to be 2, because complex plane contains every circle, right? Every circle is of radius r with center 0. So then by Cauchy inequality we have n factorial times some constant, because I am fixing the radius around 0, so it's r equal to 2. So I am fixing this circle. So this is 2 minus 2. So this is a constant divided by 2 to the power n. Now what the options are saying, that n to the power n, if n okay, so if n0 is n factorial times n, if n0 is n minus 1 factorial, and I forgot the last option, n factorial times n to the power n. So if n at 0 is n factorial times n to the power n. Yeah, now just put this in the inequality. So for this, n factorial times n has to be less than equal to n factorial times m 2 to the power n. So which will give you n times 2 to the power n is less than equal to some constant. But this is not true. This is certainly not true for large n. So this option is not correct. So now let us say if n0 equal to n minus 1 factorial. So n minus 1 factorial is less than equal to, by Cauchy inequality, n factorial times m divided by 2 to the power n, which will give you 2 to the power n divided by n less than equal to m. Again, this is not true. for large n. Finally, n factorial times n to the power n. So if n0 equal to n factorial times n to the power n, which is less than equal to 12 divided by n divided by 2 to the power n by Cauchy inequality, which will give you sorry 2 to the power n times n to the power n is less than equal to m. Again, this is not true for large n. So these three options are not correct. This is the right option. Okay, let's move on to the next problem. Problem number 4111. If be an entire function such that f of c is inside x plus iy such that y equal to x plus 1. So the image contained in this straight line. So we know for entire functions we have open mapping theorem. So that means the image of an open set U is open. Okay. So let's consider an open set U inside C. When the image is open, every open set in C contains a ball. But as the image of FC is contained in a straight line, that certainly does not contain any ball, open ball, does not contain any open ball. So F has to be constant. So open mapping theorem is for non-constant holomorphic function. So F has to be constant. So mod of F tends to infinity as Z tends to infinity, it is not correct. If Z by Z tends to 0 as Z mod Z tends to infinity is true. Z times f of Z tends to 0 as Z tends to infinity. This is not correct. If Z tends to 0 as Z tends to infinity, this is also not correct. Okay. Yeah, so these 3 and 4 can be true when f of Z equal to 0. But the point is 0 does not inside the set x plus iy such that x plus 1 equal to y. So if is a non-zero constant, so that's why f of Z by Z tends to 0 at mod Z tends to infinity is the correct option. Okay, let us move on to the next problem. Problem number 4113. Let A be a subring of fields of rationals Q such that any non-zero rational R, we have A, R is belongs to A or 1 by R belongs to A. Which of the following statements is false? So I don't have enough space here, so let us just do it here. A is a subring of Q. So okay, let us consider a statement that let statement 1, let us denote is that S 1 by P is belongs to A for all prime P. Okay, then I claim that 1 by N is inside A for all n belongs to natural number. Why? Because as A is a subring, 1 is inside A. And we assumed that 1 by P is inside A. That means any prime power is inside A because A is a subring. Okay. And we have prime factorization of for any natural number. Okay. So as 1 by P to Pi is inside A, that will imply 1 by Pi power Ni is inside A. Okay. Now just take the product from I to K. We have 1 by N is inside A. So as 1 by N is inside A, we have M by N is inside A for all M belongs to Z and N is inside natural number. So in this case, A is equal to Q itself. Okay. Now take the converse of this. I mean, if S1 is true, then S equal to Q. If S1 is not true, S1 is not true. So that means there exists a prime such that 1 by P is not inside A. So I claimed, so the point is that the converse, I mean if the negation of S1 implies this 1 by P is not inside A for a prime. So there could be other primes such that 1 by Q is not inside A. So I claim that this case is not possible. So my claim is for two distinct prime numbers P and Q, distinct primes P and Q. So 1 by P is not inside A and 1 by Q not inside A is not possible. That means either one of those inside A. So let us just assume 1 by P is not inside A and 1 by Q is not inside A. So now consider P by Q. So by the condition of A, for every rational, either R is inside A or 1 by R is inside A. So either P by Q is inside A or Q by P is inside A. Correct? So, and P and Q are distinct primes. So we know if as P and Q has no common factor because these are distinct prime, so we find integers x and y such that px plus qy equal to 1, right? So now let us assume p by q is inside A, then p by q is inside A implies p times x divided by q is inside A because A is a subring. Then px by q plus y is inside A because y is an integer, right? Every integer is inside A because A is a subring. So that will imply px plus qy by q is inside A. Yeah, as I told before that z is inside A as A is a subring. So that will imply 1 by q is inside A because px plus qy is 1. So that is a contradiction because we assume that 1 by q is not inside A. A contradiction. So that means p by q is not inside A. And similarly, let q by p is inside A. Okay, that will imply qy by p is inside A. That will imply qy by p plus x is inside A. Because as x comma y belongs to z, so that will imply qy plus px divided by p is inside A, which means 1 by p is inside A, but we assumed 1 by p is not inside A, so that means q by p is not inside A. But that contradicts the fact for every rational number, for all rational, r is belongs to A or 1 by r is belongs to A, non-zero. So that means That means among 1 by P and 1 by Q, one of them has to be lie in A. Okay, one of them has to be lie in A. So if S1 is not true, that means there exists a prime 1 by P which is not inside A. This is the only prime. This is the only prime such that 1 by P is not inside A. Okay. Okay. So far so good. Yeah. So what that means, that 1 by Q is inside A for every prime Q which is not P. Yeah, as I proved here. So if P does not divide N, then 1 by N is inside A, because N has a prime factorization, and P does not divide N implies none of them is P. So as we showed before that 1 by Q is inside A, so 1 by Pi is inside A, as Pi are not P, so that will imply 1 by N is inside A. Because as 1 by Pi is inside A, then we can take any power, as this is a ring, and then take the product over distinct i's. So from that we can immediately see that M by N is inside A for all M belongs to integer and P does not divide N. Okay, this is the first observation. Now I am claiming that if okay, now I am claim take a rational number such that GCD of A comma B is 1. This is the reduced form, because we can write every rational number in a reduced form, and P divides B, then A by B is not inside A. Okay, so proof. So P divides B means B equal to P times some D, right? So A by B equal to A by P times some D. So let us assume, by the sake of contradiction, let us assume A by B is inside A. That implies A by PD is inside A. That will imply, just add this guy D times, because as A is a subring, that will imply A by P is inside A. And this rational number is in reduced form, so then GCD of A comma B is 1. That means GCD of P comma is also 1, because P is a prime factor of B. Now as GCD of P comma A is 1, then we can find integers x and y such that ax plus py is 1. Okay, so now A by P is inside A implies, from this A by P is inside A implies ax by P is inside A. That will imply ax by P plus y is inside A. That will imply ax plus py divided by P is inside A. That will imply 1 by P is inside A. But our conclusion is that if S1 is not true, then there exists a prime. This is the only prime such that 1 by P is not inside A. So 1 by P is not inside A. So this is a contradiction. So this claim is true. So every rationals such that GCD of A comma B 1 and P divides B 1 by A by B is not inside A. Okay, so then what is A explicitly? A is those rationals, and I showed that if P does not divide N, then 1 by N is inside A. Then M by N is inside S for all M belongs to Z, and P does not divide N. So A by B such that GCD of A comma B is 1 and P does not divide B. So this is the whole collection, right? So you can see easily this is nothing but the localization of Z at P. Okay, so now this is a local ring. So now the set in the first option S is given by A belongs to A such that 1 by A is not inside A, union 0. So let us just decipher what is the set is. So let's say M by N is inside S. Let rational number is inside S. So this is what? This is M by N belongs to A such that N by N is not inside A, but A is Z localized at P. So N by M, yeah, of course, in the reduced form, because we can write every rational number in reduced form. Reduced form means GCD of M comma N is 1. Okay. So N by M is not inside ZP. That means P divides M. If because if P does not divide M, then N by M is inside Z mod, Z localized at P by the definition, right? So that means P has to divide M. So what that means, M by N belongs to S implies P divides M, and conversely for any rational number A by B, rational number A by B in reduced form, if P divides A, then A by B is inside S. Why? Because look at B by A then, and P divides A. So this is not in the set, right? This is not in the set, right? As we showed before that so if A by B is inside Q and GCD of A comma B is 1 and P divides B, then A by B is not inside A. So so here if P divides A, then B by A is not inside Z localized at P. So what that means? That means A is equal to the collection m by n such that GCD of m comma n is 1 and p divides m. Right? So b by a is not inside z. Yeah. Conversely, for a by b belongs to GCD of a comma b is 1. If p divides a, then b by a is not inside zp. That implies a by b is inside the defining set S. Right? So what is S? S is m by n such that GCD of m comma n is 1 and p divides n. So which is nothing but pzp. Sorry. Yeah, so you have to take the union with 0. So this is pzp, right? So this is the unique maximal ideal in the local ring. Maximal ideal. Additive subgroup. Prime ideal. Okay. So that means the conclusion. So what is the conclusion? Conclusion is A is, there are two possibilities of A. A is Q or A is the local ring Z mod P at for some prime P. For some prime P. And we know the properties of these local rings, okay? This has unique maximal ideal, this has unique maximal ideal. Okay. And one prime ideal. Yeah, so which is PZP. So that means, returning to our question, which one of the following statements is false? As we showed, yeah, if A equal to Q, this set is 0, and if A equal to Z localized at P, the set is PZP. Sorry. Okay. Yeah, so this is in both cases these are additive subgroups, so this is true, so we will not take this. A has at most one maximal ideal. This is true for these two possibilities, so we will not take this. For any non-zero A comma B in A divides B or B divides A in A. So let us just prove that. So in Q, the option 4 is true trivially. So in ZP, when A equal to ZP for a prime P, let us say M by N is inside ZP, M prime by N prime is inside ZP. Then write M by N equal to M prime by N prime times N M prime divide over N prime M. Am I writing correct? Yeah. So these are all in reduced form, and these are M by N and M prime by N prime in reduced form, and yeah, and as they are inside ZP localized at P. P does not divide N. P does not divide N prime. Okay. Okay, now we can write N prime times M divided by N M prime in this fashion: P to the power some K A by B, where K is an integer and P does not divide A, P does not divide B. We can write every prime number in this fashion. So basically K is the periodic valuation, if you know the stuffs. So you can write this fashion, so just replace it. P to the power K times A by B. So if K is positive, k is greater than equal to 0, then p to the power k times a divided by b is inside Zp. Right? Why? Because p does not divide b. And if, so yeah, in this case, if k is positive, in this case, m prime divided by n prime divides m by n in Zp. And if p is less than 0, then just take m prime by n prime equal to m by n times p to the power minus k times b by a. Again, then if k is less than 0, minus k is greater than 0, then p to the power minus k times b by a is inside Zp. In this case, m by n divides n prime by n prime. So the fourth option is true in both cases. So fourth option is true. We will not take that. So now as a is not, now check, let us check option 3. As a is not equal to q, that means a is equal to z localized at p for some prime p. And this is a DVR, by the way. This is a DVR. So that means every non-zero ideal looks like p to the power n Zp, n greater than equal to 1. And the zero ideal, you can take the zero ideal, and every non-zero ideal are of the form p to the power n Zp. So among them only prime ideal is pZp. So that means there are only finitely many prime ideals. So this is false. We will take this. So see you guys on next video. So after that we will continue. So thanks for watching.